Greetings everyone and welcome to this video on how to perform a Kaplan-Meier survival analysis in JASP. Now, survival analysis is essentially an analysis where one tries to estimate the survival, as the name suggests, of a cohort of patients. For example, consider patients who have been infected with cancer and are undergoing chemotherapy, and you want to estimate the survival of these patients, the median, the mean survival time of these patients undergoing chemotherapy. And you wonder, okay, so how am I going to do this? A very basic way would be to just note down the survival time in days, months, years, what have you, and estimate a measure of central tendency like the mean, median, or mode of the survival time in these patients. But a more elegant way would be to use what is called as a Kaplan-Meier survival analysis, and essentially it's the same thing which you would have normally done, but this gives you the benefit of customizing more features to make it simpler to understand, and to add statistical tests, hypothesis tests, to test to more subgroups in this analysis. So it's a type of non-parametric analysis. A parametric version of this would be Cox proportional hazards, and to this day, 30th September 24, JASP has not added this functionality yet, but the non-parametric Kaplan-Meier is. So let's get straight to this data set, and this data set is a similar data set. So this is a data set of patients with some type of leukemia, and this is a very simple data set. We just have three variables, three columns. The first column indicates a time, so this is the time to survival. So I guess this is in months. The authors haven't mentioned this, but let's consider these to be months. The status 1 or 0 indicates survival. So 1 indicates death and 0 indicates a censored data. Now we need to understand what censoring means in survival analysis. So essentially, when we conduct a study, say from January of a certain year to, let's keep it simple, to say June of the certain year, end of June, we have 6 months of data, and within these 6 months we estimate how many people or patients have died and how many have survived at the end of these 6 months. And now after these 6 months, it is but obvious that more people will continue to die, and we can't estimate what time they actually die because we have not followed them up, because our study protocol only had these 6 months in mind. So we can't label them as survived patients or dead patients. So that's why we use a neutral term called censored. So these are essentially censored patients. So 1 indicates death and 0 is censored. And the third column, X, is whether so a chemotherapeutic drug has been given to these leukemia patients and whether that drug was maintained or not maintained. So essentially, we want to check what is the median time of survival in this cohort, and then we want to go further and check out whether maintaining the chemotherapeutic regimen has made a difference in the survival, or if that does not make much of a difference. And so the way to do that in JASP, the way to perform a non-parametric Kaplan-Meier survival analysis in JASP, is to click the plus icon on the far right side of the screen, on the top side, and add the module called survival analysis. And once you add that module, you will have that module along with the other tests. So it's called survival, and that's currently in beta mode. And when you drop down survival, you will get something called a classical survival, non-parametric. So we need to go there, and this will look something like this: the input variables here and the output on the right side of the screen. And essentially we have these three columns, and we see only two columns actually need to be filled to perform this analysis: the time to event and the event status. So if we do that, if we put the time continuous variable in the time to event box, and the status, that's the dead or censored variable in the event status box, we essentially have performed a Kaplan-Meier survival analysis. And we see that the median survival was around 27 months with 95% confidence intervals between 18 to 45 months. And in the next video, we'll have a look at the various input factors and how to play with those, as well as performing a subgroup survival analysis. So thanks for watching.